Space is indeed our final frontier. Once we're deep into interstellar space, I'll bet anyone we will encounter things entirely unknown to us. The question is, how can we even begin to prepare for what we're not aware of? Some encounters are likely to benefit us, whilst others are likely to utterly frighten us, leaving us totally speechless. Either way, out of need, not fear, and because of possible unknowns, each starship will be equipped with biolabs for both research and the crew's good and long health. Generation tanks, aging treatment, full meds, and more are a given. In this podcast, we will be discussing alien biology and providing you with a brief explanation of a realistic 2070-ish discoidal craft. For those who are new to us, we founded AsteronX and IRIS, International Research Institute for Space, for the purpose of establishing an interstellar mission to settle extrasolar planets. Not because we're doomed here on Earth, we're not, because we need more than one homeworld. All of our videos, research, etc., are to serve this mission. They are an aspect of Project AS, an interstellar mission. Enjoy the podcast. Okay, Renee, tell me about alien biochemistry.
Oh gosh, where to even start?
Big topic.
And also something I'm really, really excited about and interested in.
There's one thing I've got to say. Sorry, folks. That's really out there. Sorry.
Yeah.
Go ahead.
Yeah. Yeah.
I'm just punny. Yeah. Okay.
Yeah.
Tell us about alien biochemistry.
And really, we shouldn't say alien. I think extraterrestrial, or if we're talking about something outside our solar system, it should be exosolar.
Yeah, I agree.
All right, so... Well, I'm not going to be able to talk diversely about all possible alien biochemistries, but... And I'm not going to talk about alien biochemistry that is like our own.
Yeah, okay.
Instead, I want to say something about alien biochemistry that's radically different.
Okay.
And here I am, sounding like I'm recording a proper video in the podcast. Let's remember that.
Yeah.
Oh, gosh. Well, here, one that I've done a lot of research in because I had plans to make a video of my own about it, possibly on another channel. Is one where instead of water... Okay, so all life on Earth uses liquid water as its solvent. All proteins and other things are dissolved in water.
Yes.
Well, there's an alternative biochemistry where that seems to be plausible. I've done extensive research on it, and there is a bunch of good evidence that's showing that how it can... And you can put some links to papers that I'll send you after the podcast up on screen here. There's some, you can basically build life, not in liquid water, but in a liquid solution that's a mixture between liquid methane and liquid ethane. So basically liquid natural gas, like Titan's surface. Okay.
Okay, that's interesting so far.
Dang it, I should have had it open already, but... So one of them that's interesting is that you can build a equivalent of a fatty acid that dissolves and forms membrane-like structures in liquid methane or ethane. Let's see, I'm just trying to find it real quick. Where did I put it? Because I wanted to reference it. and give the specific name. Here we go. So it's a compound called acrylonitrile. So normally,
Pronounce that again.
acrylonitrile or acrylonitrile, something like that.
Okay.
I've never heard anyone pronounce it, so I have no idea how it's supposed to be pronounced. The number of scientists I've heard of it, probably, I don't know how common. It's not a very widely used as far as I'm aware. They have, in fact, detected in the atmosphere of Titan, which is interesting because
that is.
So here on Earth, we have lipids where one end of the lipid is hydrophobic and one end is hydrophilic. That means water-hating, water-living. And what happens is that if you have a bunch of them that bond side to side, the hydrophobic parts all cluster together in the middle, trying to get away from the water they're immersed in. Yes. And what you end up having is you have enough of them and they form a little membrane, a little spherical membrane. And that's why soap bubbles form the way they do, and that's the exact same way our cellular membranes form. They're made of lipids, and they form the same way.
Okay.
Well, this acrylonitrile, it is present in Titan's atmosphere, like I just mentioned. They found this one scientist, what's his name? Oh, I don't know what their names are, but I'll put a link. We can put a link to the article about it in the video description, and put a screenshot up on at this time. So basically, what they found is this particular acrylonitrile acts the same way as a lipid does in water, but it acts this way in liquid methane or ethane. It actually will, one half of it hides from the methane, the other half exposes itself, and the result is that it forms a little spherical membrane.
Interesting.
Yeah. And then there's another compound I don't remember offhand that will form a ladder-like repeating structure in liquid methane, kind of like DNA.
Ooh. Interesting indeed.
Yeah. And so in my research, I then found there's other compounds that are even more interesting. Like, there's a compound they recently discovered. It has a funky name, but it's cyclopropanyladine. It's an extremely unstable compound they recently discovered in Titan. At least it's unstable at our temperatures. At temperatures you might find on Titan, it's perfectly stable. Or at least more stable. And what I found is that if you actually, there's something called a, cyclopropanyladine amine complexes. And as far as I could tell, information on this is very hard to come by. But as far as I could tell, the cyclopropanyladine amine complexes may have a total energy content. It's called the standard enthalpy of formation. Very, very near that of glucose, but just whereas glucose has a negative enthalpy of formation, cyclopropanyladine amine complexes would have a positive. It just means that one's based on an oxidizing system, the other's, so you oxidize glucose to release energy, whereas the cyclopropanyladine amine complexes would be reduced.
Okay.
I guess I should probably explain right here, both for you and our viewers, what the difference between oxidization and reduction is.
Okay, go ahead.
So, oxidization is the loss of electrons, whereas reduction is the gain of electrons. So, for example, when hydrogen burns in an oxygen-rich atmosphere, the hydrogen loses electrons, whereas the oxygen gains it. Now, the interesting thing is, whereas the hydrogen burns in an oxygen-rich atmosphere, if you had an oxygen-rich atmosphere and you had a deoxidized or a pre-oxidized molecule, so then it will burn just as well. In other words, on a planet with like a hydrogen-rich atmosphere instead of oxygen, oxygen itself would become a flammable gas. Just like it doesn't matter which way it goes, whether there's more hydrogen than oxygen or more oxygen than hydrogen. So you can construct what's called reducing atmospheres that will very aggressively do the opposite. Well, rather than it being an oxidizing agent in the atmosphere in large quantities, it's a reducing agent, like hydrogen. Hydrogen's probably one of the best.
Opposite chemical reaction.
Yep. Hydrogen, for example, if you expose it to metals, I guess you could call it the inverse of rusting happens, where it's called hydrogen embrittlement. It shoves itself into the metal's framework and causes it to bubble and burst and become brittle. So, you can have an entire backward or inside-out ecosystem, chemical system in the atmosphere. So, and as part of that, and also you can build it all at low temperatures, where things that are extremely unstable at our temperatures are just stable enough. Like glucose is stable, but also somewhat unstable, and that's why it has so much energy potential.
Okay.
Likewise, a cyclopropanidine amine complex may have a similar balance between stability and instability at temperatures you might find on a planet like Titan.
Okay.
Titan, honestly, though, it's not a perfect planet for these temperature ranges. It's mostly icy rather than rocky, and it's actually cold, for liquid methane. Titan is hot, and hence it has a structure kind of like some desert planet. Yes. Dry equator and wet poles. If it was a little warmer, though, it could switch to predominantly ethane instead. Ethane is... what's its chemical compound? Dang it, I had this stuff memorized, but then it's been a while since. That's 2 carbon atoms and 6 hydrogen atoms.
Ah, okay.
So C2H6. And you can have lakes of that, and pretty much anything that will dissolve in methane will dissolve in ethane.
Which in itself is really fascinating.
Yeah, it is amazing that you can actually... you start digging into it and you realize, you could potentially have a working biochemistry at these temperatures in a reducing atmosphere. So that means a habitat on such a planet full of oxygen, that'd be like having a dome full of hydrogen here on Earth. It's highly explosive, potentially.
Yeah.
And also, by those temperatures, we're effectively made of lava, with lava for blood.
Yeah.
I mean,
now,
water.
That's a thought.
Liquid water is as hot to titanium temperatures as molten sulfur is at Earth temperatures.
Yeah.
That gives you some food for thought.
Ouch.
And actually, on that, makes you wonder: can you have the reverse? If you can have something that much colder work, could you have something that much hotter? And it turns out I haven't done so much research in this. So this is more superficial research, but
okay.
At about the same temperature range above terrestrial temperatures as Titan is below, you can have fluorocarbons. That's rather than hydrocarbons with hydrogen bonded to carbon, you can have fluorine, which has much tighter bonds, bonding to carbon in place of hydrogen.
Okay.
And you can have fluorocarbons in forming different compounds in molten sulfur.
Oh.
Say, a planet with lakes and oceans of molten sulfur. So, some of you might remember the Tholen. No, not Tholen. The what was it? Tholians? The Tholians from Star Trek.
Oh,
like the Tholian web. And they're supposed to be at like 400 degrees temperature. And their appearance, they just appear to be glowing red hot. Their eyes are just white sockets. Basically, a creature native to those temperatures would look to us like we do in an infrared camera. in a far infrared camera.
Yes.
Basically,
Okay.
the mouth and eyes are just glowing holes, and the whole body's glowing red. It's but I mean, to a species native to titanium temperatures,
Yeah.
well, we're just as terrifying looking.
Yeah, we would be, wouldn't we?
Yeah, we look pretty terrifying to titanium temperature, to a titanium native. If you had a native. The ideal kind of planet for the colder temperatures now would probably be what they call a carbon planet.
Okay.
That's a planet where, unlike Earth, which is a lot of silicon, a carbon planet is instead carbon rich.
Just to clarify to our audience.
Yeah.
Or although we are carbon units, as everyone says, the planet is primarily.
Earth is a silica planet. In other words, it's right. Made of a lot of silicon and oxygen with iron. Whereas a carbon planet is a theoretical planet that contains more carbon than oxygen.
Yes. Okay.
I don't know if we might have a couple of them out in the Kuiper Belt or Oort cloud. That's an open question. We might.
Yeah.
Speaking of which, the habitable zone for a planet at such cold temperatures would have to be as far away as Saturn, at least. Or between the orbit of Jupiter and Saturn, equivalent.
That's a ways.
Yeah. And I have even more to say about the... Yes. I could go on like all day about the cold planet temperatures. I'll just kind of go over some more things here. Acetylene could also potentially work as a glucose equivalent, but it's not very energetic. And there's another one called cyclohexane, which can adopt two different stable structures. It basically has a similar sort of behavior as glucose, and it might work as well.
Now, you're telling us about this exotic biochemistry, extraterrestrial. You're saying that out of all of this, we could have a biology that is drastically different, and yet would it produce a creature drastically different? But we would be talking about microbes, but would we be referring to anything that could be larger? Maybe.
Of course.
Okay. Could you speculate on that a little bit?
The thing is, there, to really work that out, you have to, and this is what I had started doing before, but
yes,
the project's been on hold for a while. You have to start from some basic ecosystem and then work the creatures forward.
Yes.
It could end up non-humanoid, it could end up humanoid, it could end up non-intelligent, it could end up intelligent. There's no reason it can't.
So
it's still all can work out, but as long as the basic biochemistry can work out the same, there's no reason that more complex can't work.
Okay.
It's not like there's some fundamental limitation. If the basics work, everything works.
You know, I have to ask, and I'm sure others out there would be very curious. In Star Wars, they show all manner of creature. In Star Wars, they show all manner of creatures, extraterrestrial life, looking extremely different. What are your views on that?
Well, my view is probably going to be a little controversial, but I think, for one, that we're going to find that humanoid, even very humanoid, is going to be more common than we anticipate. It's kind of a naive assumption to assume that any extraterrestrial has to look different.
Yeah.
There's a thing called convergent evolution. And the thing is, for an intelligent, verbally communicating, tool-using, land-based species, the humanoid body form is somewhat unparalleled. Whenever you imagine an alternative that deviates very far from humanoid, you can think of already disadvantages. Like, if you had a kind of where maybe the creature had 4 rather than 2 legs and 2 arms, so kind of centauroid. It might not look anything like a centaur, but like it has 4 legs and 2 arms.
Okay.
Well, it doesn't strictly need those 4 legs. It could balance on 2 like we have.
Right.
And aside from that, but evolution's not always about the most efficient. It's about what works for its environment, and if that works better than the next equivalent, it outcompetes. That's all.
Yeah.
But it is at a disadvantage in terms of, well, it does require significantly more food unless it's smaller. That has a point. Maybe on lower gravity planets with less traction because of lower gravity, and also therefore reduced mass to support. Maybe you could have, or alternatively on maybe higher gravity, you might have in lower and higher gravity tendencies toward more or less legs. It's very extremely variable. I think what we're going to find is pockets where you have this or that planet with similar conditions. I don't know if they'd be clustered in space or not. I think that we're going to find a mixture. I think we're going to find a lot of species that are both very similar to us and extremely different.
Okay.
Now, extremely different does not mean find the most wacky, exotic design you can.
Right.
It just means something different. And
yeah.
Like, what if you had a species that evolved to use radio waves, or maybe more likely vector radiation, the null radiation that we talked about in the Singularity podcast, and I'm talking about in the Singularity video and the companion Tachyon video.
Right.
What if you had a species evolving to primarily communicate that way, maybe an aquatic or amphibious species?
Okay.
They might then deviate from humanoid, like if they don't primarily use their vocal cords. We have a quirk where we cannot swallow and breathe at the same time, whereas a human baby or cat or most animals, they can't. Well, a species that is in the water has some problems with vocal communication. I mean, dolphins manage it, but it requires a very, very different body form.
Right.
Another option would be if you developed some manner of telepathy, and there's a couple different ways you might do that, but some kind of telepathy or equivalent. Then what you could do is the esophagus and windpipe can be just designed for food and breathing. It doesn't need to be for talking.
Right.
And the mouth might, especially if they're aquatic, like you might have a large mouth where where it might have kind of cheeks, but it might be split further back.
I see. Okay.
And their face a little more smoothed over and streamlined with just small closable nostrils.
Right.
That start to have an almost fish-like face by our perception.
For hydrodynamics, yes.
Yeah. But then you could have very different body forms, like potentially really, really different. I mean, you could probably... I'm not sure, it's an open question. Can you develop intelligence without the means to manipulate your environment? I kind of personally suspect that you only get so far without the ability to use tools.
Yes.
It will hinder the growth of intelligence beyond a certain point.
Because the act of picking something up, holding it in your hand, and utilizing it as a tool serves to advance the brain, advance the consciousness.
Or give an incentive for it, yeah, because if you have the ability to very readily manipulate your environment, then being more intelligent gives you a distinct survival advantage. Whereas if you can't really manipulate the environment, being a bit smarter isn't necessarily going to help.
Yes.
I mean, you might outthink and outmaneuver, but if you can't really manipulate your environment, that will only help you to a point.
Yeah, there could be
humans are the most dangerous predators on the planet, primarily because of our ability to use tools.
Yes, this is true.
Our wrists appear to be optimized for throwing things or swinging things.
Right.
So our bodies have evolved to specifically make use of tools.
And obviously we have the brain to match that, which tells us a lot.
There's in my opinion, naive thought that humanoid is not optimal. I'm not sure where that comes from, but it kind of breaks the scientific assumption, and that is, rather than assuming there's something unique or special about us, we assume that not really. While superficially it seems like, oh well, assuming the human body form isn't particularly adept, maybe it's even one of the bad ones, a bad design. That actually is not really following that, because assuming there's something special about us, that we're particularly ill-adapted at our environment.
Right.
The neutral point of view is to just that, to look at it neutrally. And the fact is that, well, our bodies do seem quite well adapted to our environment. If you look around, everything you're looking at, humans have built directly or indirectly.
Right.
And when you think of any major changes to human being, you start to run into problems. Now, that's not to say you can't have... You can still have non-humanoid, and that could happen either due to some quirk of the environment that makes that better, or to some just random chance where that just happened to be the one that became intelligent. And you can also have sort of humanoid, where you might have it where the creature this being looks superficially reptilian or insect-like. Now, that's not to say they wouldn't actually be true reptiles or insects for two reasons.
Right.
One, those technically only refer to creatures native to Earth. You could have something that is practically like an insect in almost every way, but is native to a different planet and would be not technically an insect. But furthermore is that an insect has a not very differentiated brain. It's pretty much just a nerve strip running down its back and a little tiny cluster at the front. I mean, cockroaches can run around headless and will operate just fine until they starve to death because of a lack of mouth.
Right.
But if it had a mouth still but no brain, it could still function almost normal.
Yeah, well, there are moths that have no mouth.
Yeah. That's also why you can have those zombie ants where a fungus can infect it, because its brain is so simple. An ant is basically a biological robot. And the fungus can produce chemical changes and cause it to just march around and operate it.
Yeah, that is
something
really
more
strange.
Yeah, but something more advanced, it can't work because the brain is far too complicated.
Yes.
There's ants that will continue chomping on a leaf while in the middle of a wildfire, as once they're literally bursting open. It's like,
yeah.
they act like robots, like it's just doing its task right up until the moment it can't.
Automatons of a sort. Yeah.
Yeah.
It's collectively they work together. Yeah.
Whereas an intelligent species, and also there's the fact that they don't have lungs.
Oh, right.
Whereas an intelligent species that looks like an insect would only be insectoid, insect-like.
Right.
Like they'd have a chitin-like exoskeleton, but they would have differentiated internal organs, they'd have lungs, they'd have large centralized brains. They'd only look superficially insect-like.
If you don't mind me taking this to another little bit of a different direction.
Sure.
When we are out there exploring space, in interstellar space, there's a possibility we might encounter another species that's intelligent, that has ships, but doesn't look much like us, if like us at all.
That's actually a very good point. There's an artist that I follow on Twitter, where he has these intelligent species where they have 6 limbs, but they walk on 4, and the other 2, the front 2, there's some. No wait, do they have 4 limbs or 6? I have to look again, but they're not humanoid, and yet they can still have graspers. Either they have
Interesting.
6 limbs and they use the front 2 like arms, or they have 4, but when they're not having to walk on them, use the front 2 like arms. Something like that.
Uh-huh.
And they're not humanoid, their face doesn't look humanoid at all. But he's had it and showed it looking very plausible what their technology looks like. And
Yes.
it looks subtly different than ours, but also very similar because, I mean, a wheel's a wheel. And if you have a truck, it's like, if it's a more, like if it is lower to the ground, like it has 4 legs and 2 arms, yeah, maybe the vehicles are a little more squat and smoothed over than ours. Like they don't have such tall windows because they're not oriented the way we are.
Well, that's a good point. A wheel is going to be a wheel.
Yeah, and it also means a vehicle, a wheeled vehicle, is going to look like a wheeled vehicle, even if the driver doesn't look anything like a human.
Yeah, that's a good point.
Like these creatures also have another quirk, is that they have 4 eyes on little stalks, so they can, and their brains are able to integrate complex images from those, so they can just look around in all directions with their eyes, and have a complicated vision image and not get disoriented or anything like we would. Well, that means that their windows, rather than just being like in front of them or something, they might have a lot of little portholes that they peer out with one eye at a time. And so to us, it looks more like some impractical concept car or a drone or something. But to them, it's just... It also means that to them, it's more... He has it where they just went into VR for vehicle piloting a lot sooner.
Okay.
Because it just fits their eyes and their brains being structured to sort and put together complex images from many directions in a seamless manner. That makes them much more predisposed to VR without getting dizzy or motion sickness. So they have a headset that their eyes go into and it feeds a different image to each of their 4 eyes from cameras outside, and it just makes sense to them. Their brain's able to integrate it. So there's subtle differences. It's fascinating to see both so similar yet subtly different. And then you see the pilot get out of the vehicle. It's like, they're not humanoid at all.
What gave it away?
Also, communication might be a little difficult because there could be sounds an extraterrestrial can make that we just simply lack vocal structure to make at all.
Yeah.
We might even be unable to... So in other words... When you learn an extraterrestrial language, unless they're actually humanoid and very similar.
Yes.
Really, when you speak their language, you're going to be speaking an approximation, where you use some sound a human can make that sounds close.
Oh yes. Okay.
Likewise, when they speak ours, and if the vocal structure is different enough that we just can't make each other's sounds well enough, then we'd have to rely on voice synthesizers instead to talk to each other.
Yeah.
And as for ideas of alien compatibility...
Wow.
First of all, the genetics are going to be different. Now, I personally think that there's not that many different ways to orient the genetics. So in other words...
Okay.
But it's still... Just like how a cat has wildly different genetics and we do it, it's... The only way you're going to have different extraterrestrials are compatible is if they're not entirely unrelated. Like, in other words, if you had some species that in a past era spread out, built an interstellar empire, which... That's another topic for another video about how real interstellar nations or interstellar empires would actually have to work. I'm not going to go into here.
Okay. Yes.
That could be another podcast.
Yeah, that'd be great.
I think you would have a lot to say about that too.
Perhaps.
Because that goes into psychology, and that's kind of your field there.
Yes.
So
philosophy,
but
psychology.
I will say,
okay.
But just let's say you just had some species that spread out, whether empire or non-empire, whatever. Yeah. And then their civilization collapsed for various reasons, like infighting, population, environmental destruction. I don't know. The number of the ways they could collapse are many.
Yes.
Or maybe they even got into a tussle with another species and it ended in mutual destruction. But now you have planets that are now returned to Stone Age, where you might have it where perhaps every few hundred galaxies, like in others, you might have it where if there's only so many ways to arrange a genetics, you might just get lucky, and if you travel far enough, find, dang, this planet has turned out very similar to our own. And here's a thought: if convergent evolution creates similar outward appearance,
Yes.
might convergent evolution also produce similar genetics? And there's also the
Sure.
fact that our genetics, the part that makes us different from, say, a chimpanzee or even a cat, is only a small percentage.
Yes.
So you could theoretically take a native species that had the same chemical building blocks of their DNA
Yes.
and insert a tweaked version of your genetics just enough to make them look like you or very close to like you.
Yeah.
And potentially even, well, compatible if you're so minded. And a species might, during their expansion phase, before they grow up and cut that out or else collapse,
Yes.
might go around and do that. So you might have a cluster of systems near each other where they're like, hey, you look like me. Yo, you look like me. And then later they find out, because
Yeah.
intelligent beings are intelligent beings, humans are humans, even if they're extraterrestrials.
That's right.
You might find out that, oh, we're kind of compatible. How the heck? Then they start digging and find ruins and realize that they're all the direct or indirect descendants of another species.
Right.
Ooh. Well, that explains that.
Which I'm sure actually happens out there. And there is one other thing that's kind
And the thing is that
kind
you
of
wouldn't
related.
necessarily know.
You wouldn't. Right.
Not for a long time. Because you wouldn't know, is that small difference in your DNA natural or artificially created?
That's a great
How
point.
would you know?
That's a great point. No one would know until, well, you start to learn a little more. But on that note, what about the potentiality of maybe a more advanced species that engineered themselves? I was referring to a species that might completely genetically alter themselves.
All right, so your topic now. You have your notes about a Discoidal craft 2070s.
Okay, my topic. I absolutely love this. And before we get into the nitty-gritty of this craft, I wanted to let everyone know that we're still working on the promised video, The Reality of Achieving Faster Than Light Interstellar Travel. It is on the way, and most likely that one will be published before this one about the craft will be. But no guarantees. That's a complex video. So, yes, this craft, Renee and I have been working together on multiple different spacecraft. We need one for interstellar, we need one for transstellar, which is encompasses both interstellar and interplanetary, and we'll explain that in another video. But this craft is, and this is going to be a schematic of a discoidal. It is designed for operation around about the 2070 time frame. It is a realistic design. It measures 200 meters in diameter with a height of 18.2 meters. And it will be capable of landing on a planet with the Earth gravity. All around the perimeter of the ship are 224 photon drive units, each powered by an antimatter reactor.
Okay, hold on. What do you mean about photon drive unit? I think you need to back up and explain that a bit.
Okay, so how can we use photons to propel a craft? Well, you've got to think in terms of mass reduction. The drive uses the same null radiation we mentioned in the singularity converter video or podcast, which the craft can couple with the more energetic side of the quantum vacuum, allowing the craft to push against this massless energy. It's not a physical object, nonetheless, the craft can still make use of it. The craft can not only make use of it and push against it, but it can also draw energy from it. And therefore, if we can partially push against it, the amount of energy the craft needs to expel, the amount of effort needed to move it is reduced. So the effective inertia is also reduced. The amount of energy bound up within the quantum vacuum makes a neutron star look like a matchstick. Within the kind of energy densities, being able to ping it and get it moving, creating a feedback loop, and then encompassing the entire craft, surrounding the craft with this. There's enough energy to start reducing the g-forces. Collectively, the craft's effective mass is now reduced. Now the photon drive has little of the mass of the craft to push against, or to move. So in a nutshell, this is how the photon drive functions. With a craft with a mass of nearly zero, you want to use the photon drive because the velocity of the photon is, well, the speed of light. So as you can see on the screen right now, the drive units encircle the perimeter of the craft. This allows the craft to dart left or right or back and forth in a blink of an eye.
That means it can dart around in any direction.
So when you turn your flash, if your flashlight had no mass, the moment you turned it on, pew, there it went. The velocity of the drive, of course, is critical to allow us to get up to the speed of light and then jump through space. And if you want an explanation of the jump drive, we have a video specifically called the Musha jump drive. Have a look at that.
And that's another... We've touched on that in the old Musha jump drive video. We will talk about... Yeah, we'll
need a new one. Yes.
Yeah. Sorry, I got my tongue tied up there.
Yes.
Yeah, we need a new one, including black hole's power source, how the chronon plays in that. I'm just teasing things here, but we're going to do a new video on that.
The chronon, yeah, we do need to do a video about that. That's the time particle.
It's theoretical right now.
Theoretical, sure. Yeah. Okay, so in addition to the 224 photon drive units, are located above and below twinned warp coils. Of course, those are necessary to be able to jump through space. And if you don't mind, I'm going to leave the explanation for the video. Again, if you want to know how a ship jumps through space, see our video, the Musha jump drive. Okay, so what you're seeing, those wide gold bands, that's the warp coil housings. Inward from that, you're going to see the antimatter and fusion reactors. The antimatter has the gold and red containment chambers. There's a toroidal fuel or propellant tank that is connected to the fusion reactors. And then inward from that is the habitation module. Now, some of the components, life supports and so on and so forth, will be contained within the habitation, so there will be air around them in order to access them during flights. Inward from that is the center of the ship where the control center will be. And of course, that's located at the very center of the ship. Each deck, each floor, is roughly 3 meters in height. So it's rather tall ceilings is necessary so that not to have a claustrophobic feel. And all around the perimeter of the room will be viewing screens. We're going to have cameras and viewing screens. Having the control center at the very top of the ship to have some windows is a nice idea, and at the very top we will have some small little windows in the event that we need to. But for the most part, we're not going to make the CC vulnerable by putting it at the top. Should something hit the ship, and well, there you go. There goes your ability to control the ship. Having it buried at the middle, for those of you who play certain combat games and you build a ship, you know that putting this control center at the center of the ship protects it. There's a lot of material in the way to get to it. Now, we're not only going to have 1 or 2 power sources, we're going to have 3, maybe 4. There'll be antimatter reactor, fusion reactor, and of course a singularity converter. And why is so much energy necessary? Well, of course, the jump requires a lot of energy. But the other reason that a lot of people are not really familiar with is deflecting debris. In Star Trek, they kind of glaze over that. What is actually necessary for a relativistic ship traveling at such high velocity, we have to project a beam well ahead of the ship. The idea is one of efficiency. Sure, we could use gamma rays and just obliterate everything, but why? Just because we have all this power doesn't mean we need to use it all up. The idea here is to heat or ablate the side of the debris just enough that by the time the ship reaches where the debris is, it'll be pushed far aside of the ship. So we're just gently nudging it far enough ahead so that it clears the ship. There's no sense in doing a brute force method. That's just wasteful.
You could have a phased microwave array,
yes.
Regeneration array on the front.
Right.
There's an old design by Robert L. Forward called the Star Wisp. It has a mass of like a few grams, maybe a few hundred grams at most. And using a powerful like 10 gigawatt microwave array, which isn't that much really.
Not much at all.
You can accelerate that tiny wisp probe up to 12% speed of light in, what was it, 12? Or was it 30%? It was something, a substantial fraction speed of light in just a few days. Now when you think about then gas and dust, that has even less mass, and if you have the power of like a whole singularity converter, or like a dozen antimatter reactors, I mean, stuff like that, or even a larger antimatter reactor. Then you can blast like maybe a terawatt of microwaves ahead, or maybe not a terawatt, but what you do is 2 things. You'd have phased array so that the radiation is projected in a cone shape.
Right.
So that way everything is, and you're actually a moving focal point. You do phased array with a focal point starting near the ship and then racing away in front of it and then repeat.
Right.
In rapid sequence. So start near the ship, zoom away, start near, zoom away, and keep repeating.
Right.
And also emit the radiation where the different sections of the Regeneration array would go on and off in a circular pattern, a spiral pattern, produce a spinning, a circularly polarized microwave.
Right.
That way, any gas and dust is not just trying to be deflected forward, but you're kind of knocking it to the side a bit with the idea that a centrifugal force on it will fling it sideways.
Right.
And if you can do that far enough away, then that slight sideways motion is enough that when the ship comes racing by, the dust isn't in the way anymore. And it zooms by.
Well, the microwaves, for our audience.
Oh, hold on. And
you
you might also combine that with powerful UV and, if you have antimatter, gamma ray lasers that can ionize and ablate, partially ablate, or outright destroy any larger debris as necessary. And that way the ship is completely protected and you don't need a big, giant ablative plate in front.
Yeah. An ablative plate, a big, giant ablative plate, would be for much slower speeds, and it would be only a very, very near term, and even then maybe used no more than 5 to 10 years, because the shield technology will be up to speed relatively quickly. But those microwaves are going to heat a little side of a piece of dust. Just keep in mind, folks, you're traveling at some percentage of the speed of light. Kitty litter hitting the ship would just shred it. We have no materials.
A grain of kitty litter going at 70% speed of light,
That's right.
would explode with the force of an atomic bomb
So we don't have
on the front of your ship.
That's right. We're not going to make a ship out of 12-foot thick steel to
Besides, it wouldn't help.
It wouldn't help because there's more than one kitty litter grain out there. But as I had said in one of our videos, it's really like a cosmic shooting gallery when you're traveling that fast through space.
Oh, I just thought something I want to toss in there real quick. It's a
Please.
juicy little tidbit.
Yeah.
It's off topic a little bit, but then you can...
No,
turn
that's
to
what
yours.
these podcasts are all about. That.
We're actually working right now on a fairly comprehensive plan. I say fairly because there's a lot of variables on the further parts.
Uh-huh.
But a multi-phase plan of how to go from where we are now to at least a highly relativistic starship, maybe even FTL, in 25 to 35 years.
Yes.
Now it's based on some different assumptions, and the plan. But the thing is, the plan we're doing the plan in such a way that if there's more or less interest available, it doesn't break the plan. It just simply speeds it up or slows it down.
Yeah.
In other words, rather than it being 25 years, it could be 50. Or rather than it being 25, it could be 15. It all depends on the amount of interest and resources that are available.
Right. There's a heck of a lot of things that have to come together.
But we're working on that right now, and when the new website goes up, which it should sometime in the next month or two, maybe by January at the latest, but probably not that late. Just want to give myself some breathing room here. Well, the new website will have a list of the different phases on it, as well as a breakdown of what exactly it is we're doing and why.
Yeah.
So I just wanted to put that out there, that for those of you chomping on the bit, waiting for us to do something, well, it starts now. It might not be something physical, like we're not necessarily building something, but what's more important than building something is...
Let me say something about that.
Yeah, I think you can say it better.
For those who say, well, we're just waiting for you to do something. Well, if you haven't noticed all the videos and the topics that we're discussing, more so now, the reason why we're able to talk about all these technologies is because we have been doing something about it. But bending metal and engineering something is the easy part.
Comparatively.
The most difficult part is understanding the medium in which we will be traveling. The technology necessary to jump through space.
I think more than that,
hold on a second, is dependent on us understanding space and time, unlike what you can get out of a textbook, because it's not complete. There's a lot of assumptions that have been kept in place for too many years. We need a revolution in science, and that's what we're working on, and that's what we've been talking about. So you were going to say?
Actually, what you just said, revolution in science.
Yes.
More than just science, and then the technology too, because the hardest part is actually getting people together, all sharing the same vision and with the same, roughly the same dedication. That's the hardest part, and that's the part that we're focusing on right now. We need to promote these ideas. We need to promote the idea that... Well,
we also have another problem there.
Hold on.
Okay.
Hold on a second.
Yes.
Forget any specific plans. Well, the first thing we're trying to do is get people interested in the idea, however specifically it's done, of actually establishing a settlement on an exosolar planet before the end of the century.
Yes.
That is our objective. That is our mission.
Yes,
That's why AsteronX IRIS exists. Our objective is to establish a settlement on a habitable exoplanet before the end of this century. And it doesn't matter how it's specifically done. It doesn't matter if our ideas are completely wrong. The idea is to get people interested, not in the specific ideas, but to hell with the ideas. If we can get people interested, the whole idea is to get you guys, to get others out there, other scientists, engineers, and so on.
Yes.
To grow a movement here interested in the idea of establishing, however it needs to be done, a settlement on a habitable exoplanet before the century's over. If we can gather together the people to do that, that's the main focus. Then we can work out in excruciating detail how specifically that must be done. But that is the first and primary task. That comes before bending any metal.
Yes, there's a lot of work that has to take place, is what Renee is saying, behind the scenes before we can even start bending metal. And sure, that is going to be an exciting day. Someone asked me the other day, well, is that technology really possible? A lot of people will stop right there with that question. But we don't stop there. We say, let's find out. Let's have a look. Let's dive in and think it through thoroughly. And because we have been willing to re-examine assumptions and re-examine fringe ideas, not fantasy ideas, we have discovered many things that were right there before our noses, right in front of our faces. And anyone can do this. Well, we need people who are willing to, scientists and engineers mainly, who are willing to take an idea and think it through with us. Not say, oh, no, that's impossible because, I have 25 years of education. And,
Not to downplay that, but...
Well, no, hold on. Let me qualify that, because I'm educated. Renee's educated. Education is vital. What's important is that we just don't assume that what we already know is the final word, because it is not. There's still a lot of things that we do not know, like how are particles created, for one example. So I think we've covered that pretty good, Renee, don't you? And by the way,
I think so, yeah.
By the way, you guys, Renee and I work on everything together, whether it's the ship. There's very little that Renee does that's I don't have much of a say-so in, and vice versa. But we obviously have to do a lot of planning before we get to the point of building a starship or a spacecraft. There are necessary steps before we can even achieve that stage, and that is going to be in the reality of achieving interstellar travel. So stay tuned for that. But this discoidal craft, I would like to just sum up. It is a comprehensive, somewhat comprehensive plan. Obviously, it can't be comprehensive. There are still details that we have to work out. For instance, the warp coils. We haven't decided exactly on configuration. The photon drive, we still have a few things to work out there. We need to do some in-lab testing. Some of the more things that we will be working on in the very near future is power propulsion, which includes the MHD which is the wingless. If you want to go see that video, if you haven't already. Our fusion engine, we already have a better design. These are things that eventually you'll see videos of actual machines. But again, there is a lot, sorry to harp on this again, there's one hell of a lot of work to be done on the blackboard, on the drawing, we had to draft up, so on and so forth. I think we've ground the point into them. Do you think, Renee? and I'm going to repeat this in other podcasts and videos. Okay, so just a little bit more about the craft. In addition, we'll also talk about what the hull will be made of. The hull, Hull. Things like nanocomposites, compressed alloy, etc. There's 5 decks on the ship. Each is roughly 3 meters in height, so as to not be claustrophobic. Almost a word I can't pronounce. Claustrophobic. And in the center, there'll be the crew quarters, there'll be computer room, life support. Those will be within the habitation module so that we can gain access. Whether we will have something like stasis is still up for debate, especially when you're jumping. Might be necessary. And of course, the top speed is beyond the speed of light. The ship must be able to reach and partially exceed the speed of light. That's a conversation for another day, in order to be able to jump. And you'll see, once again, that explanation is in the Musha Jump Drive video. All in all, this ship we have roughly calculated to weigh some 5,000 to 6,000 metric tons. And yeah, that could vary by a ton, give or take a ton. Maybe not so much of a ton, but time will tell. This is not a ship we're going to be operating anytime soon. Now is the time to start developing the ship. If we wait until the 2070s to develop it, it just might take another 25, 50 years to engineer it. For the most part, engineering is not the big deal. We have to understand the medium in which we will be traversing. That is way more important. I know we touched on that, but we're going to keep repeating that over and over again. So again, we're planning a lot of different ships, a lot of other technologies. And I'd like to touch on again, today, many scientists today are either faint-hearted or they think they already know what we can and cannot do. Now, the way we operate is more akin to the way Elon Musk of SpaceX operates. We will take an idea. Now, actually, we operate even... Yeah, there's still a big difference, but there is some likeness. We will take an idea. Now, we don't take fanciful fantasy ideas, but we will take some ideas, examine them. We'll think through certain assumptions. We'll take these ideas, and again, we'll, as I said a moment ago, sorry to repeat myself, we will think it through. We will consider it, and we'll give it some amount of time. Now, the more we understand about space and time, the more we see whether some idea is true or false. So it gives us a great advantage there. So I think the videos have run quite enough. Let's conclude it there. So, did you have anything more to say? I think
I think that covers it for
Yeah,
now.
I think this is long enough. So,
Yeah, I think it's running about 40, 50 minutes now.
yes, thereabout. Well, on that note, thank you again for listening. Keep wondering about space. Thank you.